I'm Katrina King, and I'm the Senior Specialist Solutions Architect for Content Production at AWS. I also lost my voice this morning, so bear with me and we'll get through this together. Today we want to talk a little, I'm joined by Peter Postma, who is the Managing Director for the Americas of FilmLight. And today we're going to talk about color grading and finishing in the AWS cloud, and specifically an integration that we've done between FilmLight's Baselight system and AWS Cloud Digital Interface and AWS Elemental Media Connect in order to facilitate connecting a grading monitor to an EC2 instance, which allows us to grade and finish in the cloud. So today we're going to talk a little bit about a holistic vision for cloud-based post-production, color correction and color science, an overview of Baselight, concept of uncompromised image quality, and then we're going to walk through some implementation and architecture, the tip of the tongue, the teeth, the lips. And so let's start by talking about Bob. This is Bob the colorist, and as you can see, Bob is tired and Bob is frustrated, and that's because in March of 2020, Bob had to start working remotely. And that meant lots of late nights because Bob wasn't able to actually see the reference quality image that he needed to in order to do his job. So Bob would have to download copy after copy after copy and stay up late at night. And to make matters worse, 2 years later, now Bob is watching all of his friends and family start to benefit from the new normal, and he has to go back into the office. So we set out to make things different for Bob and to allow Bob to not only work remotely, but to allow Bob to work completely in a cloud-based workflow. Before we dive in, I want to talk a little bit about the Movie Labs 2030 vision and how this applies. So the Movie Labs 2030 vision prescribes that all content remains securely in the cloud and that applications come to the content. The problem is that color and finishing has always been the blocker for this. And so we set out to change that. We set out to come up with a system that would allow us to connect a grading monitor to an EC2 instance. And that will really allow us to start having a conversation about holistic post-production workflows in the cloud. So the concept here is to position AWS as the backbone of a cloud-based post-production workflow. And the key to that is the content lake. All of your content can remain securely in S3, and per the Movie Labs 2030 vision, applications can come to the content. And in that, AWS starts to act as an orchestration layer. And because we have such a commitment to open integrations, open source, and API-driven architecture, we're really trying to work to enable all different sorts of applications to be able to integrate not only with one another, but with core customer architecture. So here's the thing. We're here to talk about this today. And the problem here is that traditionally, we've always really looked at cloud-based post-production workflows as a series of of independent workloads. And so I want to kind of try to shift the narrative to start talking about workflows instead of workloads. And so we've been blocked by the color correction, the deliverables creation, and quality control from being able to really truly have a conversation about holistic cloud-based post-production workflows. And so the challenge is that if you start to talk about ingesting all of your content to the cloud without the color and finishing piece, you're essentially building a bridge to nowhere. There's absolutely no point in putting your content in the cloud unless you can do something with it. So some of you may have seen this before. We're here today to talk about this piece of the pie, but this is a concept for how we can change the narrative around cloud-based post. And it all starts with a content lake. Ingesting your master assets directly to S3 right out of the camera. The next circle out there represents core post-production workflows. So VFX, offline editorial, and now color and finishing. The next ring out is independent software vendors, partners, SaaS solutions that integrate directly with the customer architecture that can supplement the post-production workflow. And then the outer ring represents external points of integration. And so when we start to look at things this way, you realize that you ingest your assets to S3, and then they can be transcoded, and then you have a proxy. And then that can come to your offline editorial workload. And then that can come back into your S3. So the concept being that if we start looking at this as holistically, we're able to really start to benefit from the benefits of cloud computing rather than continuing to look at things individually as piecemeal. So I'm going to hand things to Peter, and Peter's going to tell you a little bit about color science and color correction, and then I'll come back and talk about architecture.
Hello. So again, I'm Peter Postma from FilmLight. I'm managing director of the Americas. I've been with FilmLight for about 15 years now, heavily involved in the color science aspects of what we do, building the tools for colorists and for post-finishing. So I first wanted to start out by kind of restating what color correction is and why it's been such a challenge in the cloud, because people have already been editing in the cloud and doing some VFX work in the cloud and stuff like that for a few years now, but color correction has proven a particularly stubborn problem to solve. So color correction is adjusting the tone, the color, and the texture of the image first by bringing together all your high resolution source material, the camera sources, the high-end VFX at the highest quality. And it's really the last creative step of filmmaking before you say, okay, this is done, let's distribute it, replicate it, send it out the door. So it's usually a very tight timeline that you have to work on because they've already set the release date for the movie or TV show or whatever it is that you're working on. So you can't miss that release date. And again, it has to be super high quality, and it's the last chance to make any sort of creative changes. So sometimes those are very dramatic color changes like I have on the slide up here, and sometimes it's just more subtle stuff, just getting one shot to match another, taking a scene that might have been shot over the course of several hours or even several days and make it look like it's all happening in the span of a few minutes. So that's the primary goal of what a color correction does, the color correction tool does, but then also allows you to really do fine-tune adjustments to kind of support the emotional throughput of the project. So you may also hear color correction talked about as digital intermediate or color mastering or picture finishing or color finishing. It's really all kind of terms for the same thing, just depending on whether you're working on episodic TV show or feature film. It may be called different things. And at FilmLight, we really specialize just in color correction. So our company got started out actually as a part of the R&D group at Computer Film Company in London, a VFX company in London. And the early stages of all our main products, our Northlight film scanner, our TrueLight color management system, and the Baselight color corrector, all existed in kind of prototype early forms at CFC. And then they just decided to split out into an independent company, which became FilmLight. We sell Baselight in a variety of different forms for on-set color correction, for color correction editorial, but our marquee product is the Baselight finishing system, which is the big control panel that you see here, to really be able to quickly make all those fine adjustments at the end of the production. So the very first production go through on Baselight was Chicken Run back in 2000. And over the past year, there have been thousands of commercials, episodic TV shows, A-list feature films that have all been color corrected on Baselight. So your typical color correction suite is a purpose-built room with a high-end reference monitor or a high-end digital projection setup, a custom control panel so that the colorist can very quickly access all the different functions of the software with just a button press. So it's not something that's typically being done, just on a workstation or in a room with light streaming in the windows or anything like that. It really has to be purpose-built for color correction. And it's often at the end stages a very collaborative process. So you have a colorist actually controlling the color correction software, making the adjustments, but working with a director of photography or director or producer to make sure that they're realizing their vision and working collaboratively. So traditionally, even today, this is done with hardware on premises. So there's a lot of storage and a lot of GPU power that's local to the colorist that they're driving to manipulate these images. And that's because at a minimum you're probably going to be doing 4K 24 frames per second. You may be doing higher frame rates. You may be 8K is becoming more common, certainly as a source material. So you really need a lot of horsepower to be able to move these images quickly. And having local hardware has been the best way to do that to date. So why are we trying to push this into the cloud? Well, one scenario is certainly, Bob the colorist who wants to work at home, as Katrina said, and it's not even necessarily that they want to work at home 100% of the time. It's just when you're in color finishing and you're waiting for VFX to deliver all their shots or the editor to deliver their final locked EDL, sometimes you're just waiting around for someone else to deliver something so that you can do your last bit and finish it and send it out the door. It'd be much nicer if you could go home, wait there, log in at night and fix that last shot rather than waiting around a facility for some footage to show up. And the other thing with the cloud that you get is scalability. So right now, you have to have hardware on premises to be able to deal with whatever kind of project walks in the door. So sometimes that might be someone who just shot something on ProRes, which is relatively easy to process quickly, and maybe it's just an HD deliverable. But then maybe you have someone coming in the door with 8K raw footage that needs to be debayered in real time and processed for 4K HDR output. So currently, you really need to make sure you have the hardware to be able to accommodate that kind of largest high-end job that you want to do, even if you're doing a job that doesn't require even a fraction of that hardware. And of course, with the cloud, you can adjust your instance that's running the Baselight software to scale to the needs of the project. And then the other real advantage is just that not necessarily that color correction in and of itself is going to be a magical thing in the cloud. If all the rest of your production is not in the cloud, it's not going to really make sense to upload everything, color correct there, and pull it on back down. But there's a lot of efficiencies at all the other points in the production workflow, like Katrina showed earlier, that benefit from being in the cloud. And so you don't want to have to pull everything down to color correct it and push it back up. If everything else is in the cloud, you want to color in the cloud too, and that just makes your whole workflow more efficient. So what do we need to do this? Well, we need lots of horsepower. We need GPUs to be able to, process a lot of pixels. As I said, at usually 4K 24p at a minimum, but some projects will have higher resolution source material or be working at higher frame rates or need to do, stereo 3D work. And you also need to be very low latency because when a colorist is adjusting the controls on the color corrector, they need to see that feedback immediately, because if they're twisting a knob and they say, oh, that looks great, and they stop twisting it, but then the picture's catching up and it keeps going, for another second, that's, not going to work. It's really going to mess up their creative process when they can't really get that instant feedback to what they're doing. So over the past few years, certainly these things have become much more easy to solve in the cloud. You can get Amazon instances that have a lot of GPUs so they can quickly debayer and process images. And you can also have them provisioned at different data centers around the world. So you get one close to you, ideally even in the same city, so you have very low latency between the machine you're working on, no matter where you are in the world. The other big thing you need, though, is reference image monitoring, because again, this is the last time you're going to be looking at the image before it goes out to the world. So you want to make sure you catch any errors or mistakes or really have the full creative vision realized in that image. And you can't do that if you don't have the proper environment for looking at the image. So that means you need a reference monitor or projector. You need, a dark calibrated environment. You don't want to have, light streaming in, hitting the screen, or you won't be able to see into the shadows and things like that. You need an uncompromised signal. Now, I'm specifically not saying uncompressed signal because you can do a little bit of compression, and I'll talk about that in a minute, but you want to make sure that whatever compression you're doing is not impacting what you're seeing on the image. So you can judge with confidence that what you're seeing is not an artifact of the compression that's streaming the image to you, but something that's maybe in the source material or something that got pulled out by grading or that sort of thing. So for a while now, we've been able to stream from Baselight, which is with an HEVC or H.265, high quality stream, and we call this tool Client View. So this is a stream that can go to a client's iPad so that they can see what you're color correcting, because certainly over the last 2 years, but even before that, the client is the director or director of photography is not always able to come into the color suite, but they still need to be able to provide feedback and say, I want this to be darker, I want this to be brighter, I want a vignette around this person, what have you. So this H.265 client view stream allows them to see that. And we built it into an application that includes thumbnails, so they can see an overview of the timeline with thumbnails and metadata and make comments and notes directly on an iPad or whatever device they're streaming it to. So that's worked very well, but there is a little bit of latency built into that H.265 stream. So often it can be up to a second or two, which is fine for a client. When you're talking back and forth with a client, a second or so of delay is no problem, because you're going to set the color and ask them, how's that look? By that time, they're already seeing the latest image. So that's fine for the client. But again, for the colorist, they can't, wait for the image to catch up when they make an adjustment. They need to see that feedback immediately. So H.265 HEVC is not super well suited to that kind of task. So one of the main ways you can save a lot of bandwidth with the H.265 codec is by using interframe compression. So, it will look at what pixels are not changing frame to frame, and we'll say, oh, this pixel is just, hanging out, so we only need to save it once. We don't need to save it for every single frame. But to do that, you need to have multiple frames in your buffer to kind of compress all together. and that is going to introduce a delay because you're waiting till you have the frames before you serve them off down to the client. So again, that's going to be introducing latency. The other problem is that it's not 12-bit. You can get 12-bit H.265. That's what we stream for the client view. And even for HDR, you know, like one of the iPad Pros, that actually looks really good. And I think a client, again, a director or director of photography can make a very good judgment off of that 10-bit HEVC stream. But if you're hooked up to a high-end HDR reference monitor, you will see some banding in the shadows and things like that that you won't see when it's 12-bit, as it should be for HDR. So you really want to be able to get to full 12-bit to, again, make sure you're having an uncompromised image. And there are other artifacts that can come out of the HEVC compression, because HEVC is really optimized for working with as little bandwidth as possible, which is great when you're trying to stream in the home, when you're trying to, you know, deliver YouTube videos and things like that, and you have no idea what people's home internet is, or you need to be able to scale depending on what their home internet can do. So HEVC is fantastic for that, but it does sometimes introduce edge artifacts and jagginess, and again, those sorts of things that aren't going to horribly detract from the image, but again, it's going to make the creative team, the colorist in particular, question, am I seeing something that's a result of just, you know, pulling the image from the cloud, or is it something in the source material that we need to make sure we fix and that we're aware of? And an important part of color correction is texture adjustment as well. So you're not necessarily just adjusting the contrast of the image and adjusting the brightness or the color temperature of the image. You're also looking at the grain pattern of the image. You're looking at how sharp the eyes are. What's the texture of the skin? Can you see, you know, the detail in their skin, or do you want to soften their skin a little bit? And those are usually the first kind of details to go when you're doing video compression. Often a lot of that detail will kind of just get lost because they assume, well, you're sitting on the couch back from your TV, you're not going to see that stuff anyway. But again, this is, you know, your last chance to look at the image creatively, and there are people who do really care about the image who are going to put this on the big screen and they'll be able to see the difference. So you want to make sure that you're preserving all the texture of the image as well. It's particularly critical for HDR. Inside of Baselight, we've built a suite of texture tools that work not just on the color of the image, but the frequency of the image. So you can adjust high frequency detail separate from low frequency detail. So particularly for HDR, when you have really bright highlights, if it clips in camera or things like that, it looks very distracting in HDR. What a lot of people will do is like just kind of back off and make the image look flatter, more like SDR. But in fact, if you just blur that image out a little bit, kind of let it naturally glow, it looks a lot more natural. So there's a tool we have called Texture Highlight, which does that adjustment. And again, it's kind of hard to judge through a highly compressed image stream. You need an uncompromised image to properly set the amount of texture highlight adjustment that you want. So what we're using for streaming out of the cloud in partnership with Amazon is a JPEG XS compressed stream. So the advantages of JPEG XS are that it's high bit depth, so you can do 12-bit. In our testing so far, we've been doing 10-bit, but 12-bit is coming very soon. And it's extremely low latency. So unlike with HEVC, where you need to at least wait for one full frame, often multiple frames, before you start compressing, with JPEG XS, as soon as you get your first few lines of pixels, you can start compressing. So before the image is even finished rendering, you're already compressing it and sending it out on the internet. And it's visually lossless at pretty decent compression ratios of 4:1 or 5:1. If you're kind of just doing like a rough color pass, you can go to higher compression ratios to save on bandwidth. And there's the potential, if you want to be truly mathematically lossless and you have the bandwidth to do that, you can go mathematically lossless as well in the future. So I'll bring Katrina back on to talk more about how this is actually implemented through Media Connect and Amazon CDI.
Thanks, Peter. So let's talk a little bit about the implementation and architecture. When we set off to do this project, we had three core requirements. It needed to be visually lossless, it needed to be low latency, and most importantly, we wanted to offload all of the computation from the artist experience and onto an AWS managed service. And that was critical because there's absolutely, to tax the artist experience in order to be able to facilitate this is contrary to customer obsession. So we built it out using two key products, Media Connect and CDI. And so what happens is Cloud Digital Interface is a protocol for moving uncompressed video within the AWS cloud. And so we integrated the Cloud Digital Interface SDK with Baselight in order to move video uncompressed directly from the application out to Media Connect. Media Connect then allows us to encode to JPEG XS with very, very low latency, and then send that over SMPTE standard 2110-22 to a grading monitor on site. We also supplemented the workflow, and I'll walk you through the architecture in a moment, with Media Live and Media Package. And what this allows us to do is once the CDI feed comes out of the application, it allows us to fork it in two directions. It goes to Media Connect, which is then transcoded to JPEG XS, but it also then goes to Media Live, which creates an HTTP live streaming package, which allows for cinematographers and directors to have an over-the-shoulder view at the same time. So here's the simple version of the architecture. So here we have the grading application, and it comes over CDI to Media Connect, and then over SMPTE standard 2110-22 to an IP-based JPEG XS decoder. We are using a Riedel decoder in the booth today, but we have options for both Riedel and for Evertz. And then that goes the last mile over SDI to a broadcast monitor. Here's a slightly more complicated version. So this is the same workflow here, but here we actually fork it off through Media Live to Media Package. And this allows a companion application to be able to take a live HTTP live streaming feed and to be able to have a director or cinematographer doing an over-the-shoulder view during the grading session. I want to throw a shout out here to Riedel and Evertz because they have been extremely supportive of this project. We are using a Riedel Fusion 6 device in the demo, which I invite you all to come see after the presentation. And we also have options for Evertz devices as well. We are currently supporting 422 10-bit, but we are in interop testing between Elemental, Riedel, and Evertz to be able to release 444 12-bit, and that date will be coming soon, but we are currently testing it. So, kind of got ahead of myself there. So 10-bit 422 is available today, and everything else will be coming soon, and we'll announce that as soon as it's available. So the other thing is we really want to encourage other use cases for this. We want to encourage master QC. We want to encourage VFX compositing. So we're at the point where we're encouraging everybody to really consider implementing the CDI SDK into their applications so that we can continue to build out on this workflow to be able to truly support end-to-end post-production in the cloud. So contrary to what Peter said about dark rooms, it's a bright new sunshiny day for Bob. Bob is able to work from home. Of course, he should close the blinds, but we're really excited to show you all the demo and to be able to really facilitate remote color grading in the cloud. So I want to thank you all for coming, and if you have any questions, Peter, come back up.